I hope everyone can hear me. It is my pleasure to introduce our speaker today, Bernard Minungu. He is a hydrologist with expertise in hydrological modeling at the AGRHYMET Regional Center. His activities include the development of decision support approaches, tools, and products on water resources, climate, and food security. He also conducts capacity building activities for national meteorological and hydrological services in 17 of the CELIS ECOWAS countries. That is the Comité intra-État de lutte contre la sécheresse au Sahel, Communauté économique des États de l'Afrique d'Ouest. He contributes to the adaptation of enhancing national climate services initiatives tools, known as ENACs, and their appropriation by national staff in order to improve climate services. We are so happy that you are here and thank you for coming. So without further ado, you can begin your presentation. Thank you.
Okay, thank you very much, and hi again, everyone. As Geneva said, I'm Bernard Minungu at AGRHYMET Regional Center, which is based in Niger, in West Africa. And I'm really pleased to be here to take part to the hackathon on S2S and to share our experience regarding using a NextGen approach in order to make a hydrological forecasting. So for those who don't know, AGRHYMET is a regional climate center for West Africa and Sahel. And our mission is to provide information, training, and research to our member states, which are around 17 over West Africa. And to do so, we are supporting our member countries regarding the data collection, processing, and disseminating information on climate, water, agriculture, food security, natural resources management at regional scale for decision makers and users. And we also strengthen technical and scientific capacity of our country and stakeholder through many kind of capacity building. And as a regional center, we also strengthen interstate cooperation by sharing tooling and technology among our member states. And our area of expertise include, as I said, climate, water, meteorology, food and nutrition security, natural resources management, and climate change. Next, please. So this graph gives an overview of a climate variability in West Africa, and is a standardized precipitation index. And as you see, we use in the past to experience either a wet period or a dry period, but recently we have a high variability regarding the climate in our region. And for this purpose, we have to adapt and set some strategy year by year in order to cope this new issue by improving the production and the use of information on climate risks. And this is really a key in order to cope with this new situation in our region. Next, please. So this is a survey we have conducted within a project which is called a Food System Resilience Program. And as you can see here, seasonal forecasting on hydro and climate variables are among the services used by our member states. And capacity building is a second services that our member states required in order to cope with climate variability in our region. Next. And for this purpose, we are promoting what we call the ENACs initiative in collaboration with IRI, that you already know, which is the International Research Institute for Climate and Society within Columbia University. And within this collaboration, we are developing and promoting many tools. First of all, in order to improve the data availability, through tools which is called a climate data tool, a PyCPT, which is a Python version of a climate predictability tool. And when it's coming to the data improvement, we are supporting our member states in order to better take benefit from the data library of the AGRHYMET, and a tool developed in order to ease the data access when it comes to weather, automatic weather data transmission. And we also promote the product used by many activities, including capacity building and communication. And among these tools, PyCPT is one of the tools that can allow us to meet user needs when it's come to a seasonal forecasting. And it allows us to implement the NextGen approach supported by the AGRHYMET. So next, please. So what is a NextGen approach? Is a systematic general approach for co-designing, implementing, producing, and verifying objective forecasts at multiple time scale, and is co-designed by a forecaster and users, and offer a tailored probabilistic forecast at multiple scale by providing information regarding the rainfall distribution and additional products such as, for example, the onset of rainfall season, the end of the rainfall season, and, for example, some additional variables such as a dry spell and wet spell in a specific region. And so the graph, this diagram gives an overview on the workflow of the NextGen approach, starting by, for example, a case study configuration, data download if necessary, and the use of climate predictability tool, which implements some statistical analysis method in order to produce a seasonal forecast in a given region. And the next step of the NextGen approach is a forecast skill assessment in order to better choose the model which are skillful for a forecast production. And one limitation with this tool is that up to now, the version developed by AGRHYMET only take into account climate variables. That means, for example, if you want to make a hydrological forecasting, for example, a stream flow forecasting, the current version developed by AGRHYMET cannot do so. And in our site, we have conducted a survey to our member states, and one result of this survey is that there was a need to adapt the PyCPT version in order to make a hydrological forecasting in our region. Next, please. So, why the NextGen approach? From the past, at the beginning of each rainy season, we used to have what we call a RCOF, a regional climate outlook forum, which gather many stakeholders, such as farmers, disaster managers, and national services on meteo and hydrology in West Africa, in order to make a forecast, a climate forecasting, and give some advice regarding the rainy season. And for this reason, we used to conduct what we used to call a PRESAS, which is a forum for the Sahelian and the Sudanian region for West Africa. And the second Outlook forum is called PRESAC, and which include mostly the Gulf of Guinea part of West Africa. And the approach we use to consider is a consensual production of a seasonal forecasting, meaning that the forecasts we use to produce are not reproducible and not traceable. And WMO recommend that all the regional center adopt the objective sub-seasonal and seasonal forecast in the region for traceability and reproducibility purpose. And this is the one reason why we consider the NextGen approach in order to meet the need or the recommendation of the WMO. Next, please. So, as I said, the version of NextGen developed by AGRHYMET doesn't take into account the hydrological variables. So, for these purposes, AGRHYMET Regional Center conduct some adaptation, which consider a predictor mostly used in order to make a seasonal and sub-seasonal forecasting in West Africa, considering variables such as sea surface temperature, wind, zonal and meridional wind, and precipitation forecast by a dynamic model. And for hydrological forecasting purpose, we consider a mean discharge for what we call the high water period for each hydrometric station over our region. And as a statistical method, we consider a multiple linear regression and the principal component regression in order to make a stream flow forecasting of the main basin over West Africa. Next. So to do so, we rely on hydrometric network over the West Africa, and is like around 200 hydrometric stations. And for each station, we try to compute what we call the average flow over the high water period. And this is the predictor or the variable that we use to predict in order to help for decision making when it's come to water resources forecasting. So the map at the left is the main river basin over West Africa, and as you can see, the biggest one is the Niger River Basin, which cover like 9 countries over West Africa. The second biggest one is the Lake Chad Basin, which cover mostly 5 countries. And we have a Volta River Basin, which cover 6 countries in our region, and additional big river basins such as Senegal Basin, Gambia Basin, and some small catchment in the southern part of West Africa. And as I said, the variable we use to predict is the average of discharge for the high water level period. And to do so, we consider a daily stream flow for each hydrometric station for the historical period. And most of stations have a data set starting from 1920 up to now. Next, please. So as a predictor, we consider output from many models, and the data of this model are available through the AGRHYMET data library. And this is just an example of a model we use to consider for forecasting, and is around 20 model for many variables, such as sea surface temperature, wind and precipitation forecast by the model we considered. Next. And as I said, the statistical approach we rely on mostly the principal component regression, which enhances multiple linear regression by addressing issue regarding the multicollinearity among the predictors. So this method arises from multiple linear regression between the response variable and the principal component obtained from the predictor through the principal component analysis or empirical orthogonal function. So going from a predictor and trying to identify the principal component that we are going to consider to construct a linear regression model in order to predict our variable, mostly the discharge for the high water period in each hydrometric station. Next, please. So in order to access the accuracy of our forecast, we use a variety of a forecast performance score based on continuous measurements and those on observed measurement, and in some cases, forecasts are used as well. And this is some example of a metric including, for example, the Pearson correlation coefficient, Spearman correlation coefficient, two alternative forces choice, and rock against normal or below normal forecasting, and generalized rock and other performance skills. Next, please. So this is just a diagram showing the workflow on how we used to implement hydrological seasonal forecasting using PyCPT we have adapted for hydrological forecasting. And the first step is, for example, the forecast setup, which include, for example, the selection of the relevant variable for the forecasting, the choice of the predictor or predictant and domain, trying to filter the predictant based on a missing value rate, for example, in order to have a consistent and very reliable data for the forecasting. The second step of this workflow is a statistical analysis and skill assessment. And this includes, for example, data download, the predictor download from the AGRHYMET data library, if necessary, running, for example, the principal component regression through the Climate Predictability Tool developed by AGRHYMET, and plotting and access the forecasting skill. And the last step of the step 3 of this workflow include forecast generation through calibration of forecast from individual model identified based on their skills, and constructing a multimodal ensemble and skill score, and saving result for exploitation purpose. So this is just a table which gives an overview of the configuration of hydrological forecasting over West Africa using the Python version of a Climate Predictability Tool. And as a model, we make some analysis, and we come out that the 4 models, for example, are the one we use to perform well in our region. And as I said, for statistical approaches, we use a principal component regression. And as a predictor, it could be, for example, a rainfall simulated by a global climate model for the rainy season. And as predictant is observed discharge, we use to compute the average discharge at each hydrometric station. And for the training period, we consider, for example, 1982 to 2016, which is the period where all the model have data. And our target period is mostly the rainy season in our period starting from April up to October in West Africa. And the predictant domain is the 7 countries for ECOWAS and SILS countries, and the predictor domain are the same. And for the assessment purpose, I already presented the skill we use to consider for the model identification and for the multi-model ensemble constructions. So next, please. So this is just an example giving how we used to consider the predictant data based on the availability of the data for the historical period, for the consistency and for the accuracy purpose. Next, please. So this map just give an overview of the model skill over the West Africa, considering the hydrometric station, where we can see, for example, the skill based on continuous variable, such as a Pearson coefficient, Spearman, and additional performance skill, such as a rock above normal and normal. Each hydrometric station we used to consider for the forecasting. Next, please. And this is how we use to make a forecasting of hydrological forecasting, considering the probabilistic forecasting at each hydrometric station and giving the forecast in this format, either, for example, the stream flow will be below normal or above normal for the coming rainy season. Next, and as some achievement, so after trying to adapt the PyCPT for the hydrological forecasting, the approach became a reference tool for regional climate outlook forum in West Africa. We used to conduct each year. And in addition to that, we try to conduct some activities regarding capacity building of national hydrological services staff in order to let them handle the approaches we have developed in collaboration with IRI in order to let them sometime update the forecast we used to conduct within the aircrafts. Next, please. And as a perspective, we plan to implement a forecast by trying to couple the NextGen and biophysical model in order to see how we can do what we call the forecast based on impact sector, using, for example, agronomic model, which is called SARA, and water resources model, which is called HYPE, which is Hydrological Prediction for Environment. And we continue to provide some capacity building to national meteorological and hydrological services through a training of trainers so that they can to spill over the method in order to cover the most step and build a local communication in order to better reach the end user needs. So this is broadly what I like to share with you, and I thank you again for the opportunity given to me in order to present the work we have conducted in order to adapt the PyCPT version for hydrological forecasting. So I thank you, and if there are questions, so I'm available to answer to them. So I apologize for my English because yes, but thank you.
Great. Are there any questions? Perhaps anyone online? Oh. Pierre writes. Do you want to pull up his? Relationship issues here. Yeah. Yes, your English was excellent. Thanks for presenting. Oh, Pierre has a question. Excellent.
Thanks so much, Ramadi. It was very, very interesting. I wonder, like you showed, and that was very nice what you presented, you know, like the different steps. Could you tell us a little bit what is for you the most challenging kind of task for subseasonal to seasonal forecast? Or in a sense, if you had a wish list, what would be kind of the one thing you would want to get, for instance, better? It could be variable or it could be a time scale. So what for you would be the most important one or the most important thing that you might not have now? Or at least you don't have the right quality right now and you would want better quality, maybe rainfall, for instance, just as an example.
Sorry, could you please repeat your question, please?
Yes, I'm just wondering what would be for you potentially the variable, or it could be a time scale that would be even more useful for your task, you know. So what would be, so if there were to be some improvement, where would you want to see more improvement in the future?
Thank you very much. And I think the first thing is what you said is the time scale. Right now, the methodology I have presented include the seasonal forecasting. But when it's come to sub-seasonal right now, the approaches we have adopted, doesn't take into account this aspect. This is the first thing. And the second thing, as I presented, right now, the method rely on the principal component regression. And we think that it will be good if we can try to test additional, for example, approaches, which include, for example, machine learning in order to improve the accuracy of the forecasting. And I think the additional thing that we could take into account is the drivers of a stream flow, for example, in West Africa. As I presented, we consider, for example, the seashore first temperature and precipitation. And for example, what is come to the seashore first temperature, we mostly consider the ENSO window. And we think that this is, for example, not enough, and we need to conduct additional a study in order to identify where, in which zone in the ocean we could consider in order to improve hydrological forecasting in our region. Just to say that we still have many challenges when it's come to improve forecasting in our region.
Great, thanks so much, and thanks for presenting. That was super interesting.
I actually have a follow-up question on that. If you're like the aspects you want to improve on, are these, do you think they're mostly limited by technical resources or human resources, like researchers working on those problems, or is there sort of a limitation in getting the data, processing the data, or is it a bit of both?
I think right now we are challenging both. First, for example, in our hydrological staff, we are like 2 or 3. We are trying to conduct this kind of study, and we think that this is not enough. And secondly, yes, we are challenging right now some technical issues, since there are some advancement when it's come to science regarding machine learning, and we think that collaborating, for example, with a center like LEAP will allow us to handle additional method which can help us to improve the accuracy of forecasting in our region. So, I hope that the 2 coming days will be very helpful for me in order to improve my knowledge regarding machine learning and regarding programming, mostly using Python. Yes.
Are there any other questions online?
Sorry, I kind of missed the first part. I came in a little bit late. But I'm wondering why, so the product of forecasts are used by the government, or is it kind of like also used by like individual people, like probably for agriculture, for insurance, this kind of thing? I just wonder what are the products of the forecasts used for?
Well,
Yes, for-
right now, we have many stakeholders which which use our product. As I said in my presentation, each year we used to conduct what we call a outlook, regional climate outlook forum, which gather farmers, individual farmers, and dam managers, for example, and disaster risk reduction staffs. So they are the mostly one which rely on using our product in order to improve their activities. Yes, so this is broadly the most users of our product. Yes. Mm.
The National Meteorological Services will attend
Yes,
those
that-
outlook forums.
yes, they
and the
attend
products.
and they contribute to the production. Yes, of the forecast. As I said, in the past, we used to gather all of them in order to produce a consensual a forecast. But right now we are moving to more objective one as recommended by World Meteorological Organization.
I have a follow-up question. How is that process going? Do you find that national Mets are comfortable moving towards an objective forecast that no longer has their, conceptual, like their agreement, their overview on?
Yes, but they are more confident because in the past we used to conduct many training in order to let them understand the methodology behind this objective forecast and to train them how to use, for example, the tool so that they are more confident and yes, and we really like these methods. Yes. Mm.
Follow-up questions. So when you kind of like evaluate like the product, is it normally just like scientific metrics, or is there feedback from like the stakeholders like, oh, we don't have enough rain, or the stream flow is missing? Is there a specific metrics that you use?
Yes, what I have to say during this aircraft, prior to produce the seasonal forecast for the coming rainy season, we used to conduct a survey, having their feedback regarding the forecast we have produced in the past. And for example, for the hydrological one, we used to have, for example, something like 65 to 70% of accuracy. Yes. Mm. Yes, and this is the activity we are conducting prior to producing the seasonal forecasting for the coming next year. Yes. Mm. Mm.
Any last questions? All right, thank you so much. This was so fantastic. Excellent.